Where does bad code come from? Let's get into it. I'm Chris Athanas. I'm a KMP developer. Tech support says they're coming out. They said they're going to close that this time. I hope they do. I'm going to be doing a reaction to this video from Molly Rocket from 3 years ago, before we had the AI boom, and we're talking about code quality. Where does it come from? And he has some good insights, but I have other ones because I think I've been doing and been in this business around this stuff for maybe a little bit longer than him. Since the 80s, 70s or so, when I first got involved with computers, and I've seen a lot of this. I haven't heard this phrase used before, but a lot of the stuff we use is conference driven and sales driven and book driven. Okay, let's get into it.
Hey everybody, Casey Muratori here. We are at the end. Start already, please do. It's for a graphic novel. This video is an invited lecture that I gave to a company called Infura.io, and I submitted like a thing saying, please give me topics that you'd like me to cover. And one of the things that I saw in a lot of the topics that came back was sort of this underlying concept of like code kind of getting out of control, like being huge code bases and slow and underperforming and so on. And so this was my attempt to give sort of a general audience answer to the question, where does bad code come from? Like, where do these problems come from? This is a two-parter. The first part is the lecture. The second part will be the Q&A. So I hope you enjoy it, and I'll be back
I'm only doing the first part
afterwards to talk about part two. Where does bad code come from? We kind of know that it's everywhere right now. Like, there's a sense, if you have experienced programming for a long time, or if you just in general look at the way things are going from a removed, sort of more objective observer standpoint, you can see that there seems to be a lot wrong with software today. And first of all, there's way too much code a lot of the times. Even fairly simple pieces of software now are like
completely ridiculous. These build scripts for these giant React applications are just basically it's a do app. And all this crazy configuration, webpack, come on.
Hundreds of thousands of lines of code, millions of lines of code, and so on. They're typically built in these very, very fragile build systems, oftentimes so complicated that they end up having to be wrapped inside things like Docker containers or things like this, even to just try and get them to keep running into the future because they have so many crazy dependencies, and there's really no way to guarantee that all the things will remain working or will remain in lockstep as they move forward. When you actually do have everything installed properly on your machine, and when you've finished having a package manager install the language, which installs its own package manager, which then goes and gets the packages, which unpack, which install their own packages, blah, blah, blah. After you manage to get all of that going, you actually can run a build. The builds take forever sometimes, things like TensorFlow or stuff like this that a lot of people use.
Ridiculous. Even build on Android has been like, how much does it cost? Are you really having to compile every damn last thing? I just changed one little thing, one button over here. I just changed one thing. I just changed this line of code over here. You have to compile everything? And it's not super easy how to break this stuff up. You have to go through this whole mishmash. You didn't think about this ahead of time? That you might need to break these things up into modules and make that super easy somehow, or this configuration management stuff. You didn't think you had 2 steps ahead? It's just, we have libraries online now. It's like, okay, what about versioning, security? Are these stuff checked by anybody? No. Just throw it up in there. We just hope for the best. Okay.
Use that are very popular projects seem to take hours to build sometimes, which is absolutely incredible if you think about how.
And these big, huge test suites that are just, are we testing Google Maps? Are we testing that arrays work? Are we testing the language here? Like, what are we actually testing? Like, for a login screen, we got all this kind of view model craziness. It's like, dude, we're just typing in a username and password. Why are we doing all this crazy amounts of testing around something that is either going to work or not going to work? It's like, what is all this stuff? And we're testing the implementation of things. I'm like, why are we testing the implementation? Shouldn't we be testing what this black box is doing, not the internals of the black box? I don't understand. This has been so I came back. So I started programming when I was in the 70s when I was a little kid. It was super simple. Just getting things running, getting it working was hard. What to do, what we could do, how to do it, and so I was pre-test driven stuff. So when I had a startup company. I did a bunch of different products. You can look at it on my GitHub. You can look at my portfolio hub as well. And you can see some of the stuff. This is all the stuff. Right. So I came back in 2012 doing Android stuff. And then all this testing stuff started becoming online, and all this CI/CD pipeline. I was like, what is all this junk? And then I go look into it. It's like, look, what are you actually testing here? What are you doing? And like every time you make a change here, you have to go redo all the tests because they're all tied to the implementation of whatever it is, because the person who wrote the test just heard about test driven, supposed to make their code better, and they wrote these tests for this implementation that you change one tiny little thing, all the tests fail. Like, totally missing the point. totally missing the point of how to structure software to be testable, to be written this way. And it's just been a mess. And this is
how much power computers have today that the things could take that long to build. When the actual software comes out the other end, the quality is not very high. There's a lot of sitting around waiting for it to do things like load or communicate with a network, and it really kind of just stalls while that's happening and doesn't really let you do very much. It's slow when it actually does things that probably...
The developer experience has been horrible. Oh my gosh. So I remember like we had Turbo C that was very popular. It was very stripped down, just did the thing you wanted to. We didn't do testing back then. So the code quality was all, the end quality result was really dependent on the programmer and how many people you had working on the thing. So the testing thing did improve stuff, but only for people who understood how to write code that could be tested. That was the whole thing. People still don't know how to do that. And not like those platforms are set up for it. There's like an afterthought on Android. On the server side, it's always been there, right? It's always, you should be testing things. And they kind of everyone did their ad hoc ways of doing this thing. But on the front end, it's been totally abandoned, like a total afterthought, like testing. What are you talking about? We're just lucky to get this thing working.
Probably should be much faster on today's hardware are not. They're still quite slow. It takes a ton of space as well. So not only do these programs now take up huge amounts of space, you have like 100, 200 megabyte executables, which is insane, and their working footprints are like many gigabytes of memory, even for doing things that seem very simple, like just scrolling some 2D images or things that are very basic nonetheless, are taking tremendous amounts of storage, tremendous amounts of memory, and just kind of...
And I'm just going to complain a little bit about this whole recycler view stuff that we had to go through with Android. It's like, this is industry standard. This is the best way to do it. And it's just changing these views on the HTML-ish page. It's not HTML. It's a markup language. It's based on XML. It's like, okay, so it's basically HTML. You've taken basically the web and you put it on this little device and locked it in this little sandbox. Okay, no, it's totally different. It's like, no, I've learned both of them, and now I know enough to say, hey, it's the same damn crap. And they're all trying to implement this stuff in all these different ways, and some of it's good, most of it's bad. And yeah, it's hugely bloated. Everyone thinks this is the most advanced way of doing things. It's like, no, this is the crappiest way of doing things. Like the fact that we have to go through all this rigmarole just to do a scrolling list of items, and we have to do all these XML forms and loading things in and having to put things in fragments. It's like, come on. This is obviously you guys have not thought this through. If you're saying that this is, and immediately when Compose comes along, we immediately drop that crap like a bad habit because it's just terrible. And anyone that's still hanging on like, I love XMLs, because you've gone through the pain of going down that one thing and you haven't looked at anything else. You haven't looked at React. You haven't looked at anything else. You haven't tried any of the other stuff that came along that made Compose even possible. And it's like, and people's like, oh, we still have to use XML layouts. That stuff's deprecated. It's gone. It's over. It's bad. It was bad to begin with. It's the worst now to start a project with it. I just got an interview at a company, and they're starting a new project, and the lead developer is an old Android head. And he came up through the Android, doesn't know web, doesn't know any of the stuff. He's like, yeah, we're gonna do the app. We're just gonna use XML layouts for this. So it's like, you do know that Google, everyone agrees that stuff's deprecated, and you should not be creating new apps based on Android. It should be KMP based and should be all composed, because then you can do cross-platform like immediately and not have to wait for it. No, we're not gonna do that. That's a little too risky. It's like, it's already recommended, deprecated, announced. Hello. It's like, no, it's too much. It's like, okay.
Very odd that would be going on. And finally, it's not like software got tremendously more reliable or something else happened. It's still totally buggy. And it has all the same problems, if not more problems, than it has always had before it sort of jumped this level of sort of kind of complexity and kind of in general this overall...
I think it's been a wash. I think with all this test-driven, all this modular, blah, it's been a wash. It's about the same as it's been the whole time. Now, bigger mainstream apps where they have teams of people doing thorough test plans and all the unhappy path, and all the things and put all that stuff into place, and for millions of customers, yeah, okay, it's gotten a little bit better. But for smaller companies, no, it's still garbage. Come on now, you guys, it's bad because developers aren't thinking like customers. And I did 2 years on tech support before I started becoming a developer, because I was going through school. That's how I was paying my way through school, was just working. And I listened to people's complaints, and man, people are only using 20% of your program. You think they're using all your 80%. You spent 6 weeks on this tiny little bug thing that no one's even clicked on it, man. And it's like, you'd be better off trying to build a QA thing that tested all the unhappy paths before you went and added one more feature.
Overriding sort of sense of decay that seems to be seeping in to whatever we call the software industry currently. And so thinking about this, if we want to actually try and talk about where bad code comes from, we have to start making some judgment calls about what do we mean when we say bad code anyway. I can talk about all those things and complain about stuff.
It's not easy to modify, not easy to understand. So good code is easy to modify, easy to extend, easy to understand. It makes sense, not using some crazy weird language thing because it's cool this month. It's you can look at it, you read the code, it looks like English. Even if you don't know what the code is, it's still you can still read it as if you did like because you don't even know because it's reading like English. And it should be look like that. That's what it should look like. That's what it feel like. It should be set up like that. And if it's not, you're off in the weeds.
Stuff. But if I don't really have some kind of a more specific understanding of what it really is that I'm talking about, it's not going to be possible for us to like get anywhere. We can't really get anywhere fixing the problem. We're just sort of saying that the problem exists, which is great, but we do have to then figure out how are we going to move forward. So I'm going to make a little bit of a judgment call here. And
you can't just complain about it. You got to say, okay, there's this other way. And that's I'm trying to do that with my channel. Is like I'm not just complaining about this stuff because that's super easy to do, but you have to have something to compare to, right? And that's what I'm trying to point out. There's another way of doing things. And if we throw away like 90% of the stuff we've been sold at these conferences and by these books, by these authors, it's like a really big game. It's solid. It's clean. It's like, stop. You guys are not helping.
And say, when I'm talking about bad code or what we should be concerned about with bad code, it doesn't really have much to do with money. If you're talking about wanting to make money, I don't think the current environment anyway, at least for the time being, really cares that much about the quality of your code. I think there's so little
No, there's this early adopter thing. It's like, oh, if we get to the country first, then we'll be there forever. It's like, no, you just showed us what it works for smaller companies to come up and take your lunch. So don't think they just got there first, and especially when you got in a zero interest rate environment, which what this video was deep inside of when it was made. When you have free money available and people can just talk their way into millions of dollars, oh yeah, code quality is not going to be the highest priority.
Competition in the software space right now because there's so much software to write. We're still relatively early in the evolution.
Still, we haven't seen the computer revolution yet. The fact that we can't go into these applications and extend them out of the box, it's all closed box stuff. That's gonna go. That's gonna go bye bye. We're gonna what Alan Kay was talking about. He's given up. He's tired. He's been doing it a long time, man. And I understand. He's just like, okay, you guys will have to figure this out eventually. The stuff that he's talking about in his object-oriented view of things, with all this message passing and the operating built up from the ground up with the operating system running on that stuff. Well, it's not possible to do that, and because there's extra levels of bloat, all that stuff can be thrown out. And we can implement the stuff that Alan Kay was talking about. So instead of these applications being black boxes, they're just they're just frameworks to extend on top of. And once that revolution hits, and people are going to have their own custom operating systems. They do all kinds of things, and they're all built just for them. And it's just the whole application stack is available, and all these applications that are once proprietary are totally open and can be extended anytime. And when that revolution happens, that's when we'll see the real computer revolution. We're still in Mickey Mouse land with this stuff.
Evolution of software. There's still so many places you can take software to that there isn't a lot of market pressure to ship high quality stuff. A lot of times
when there's zero interest rate environment as well. So if people got free money and they can talk a big talk and do the sales, just do the sales call, have a good slide deck, and then somebody's just got free money anyway, and they need to get some yield someplace, and this is the only place that's showing up that we're going over 20% yield, like over 10% yield. Oh yeah, you're gonna get a lot of people who are gonna make that bet for free. Come on.
Consumers or whoever your customers are choosing between a very small field of options. So being someone who ships a quality product, while it may be a tremendous competitive advantage if you do it, will not exactly be a requirement competitively because other people are not shipping quality software. So you really don't need this to make money yet. You might in the future, but I'm not going to try.
Well, so when I was coming up, before the ZERP happened, because he came up in the ZERP, he came up with a zero interest rate environment where all this crazy money was being put on silly ideas that should have never been done in the first place, right? So that's just the exuberance of the market and having a free money printer available for people. So now we're in this period where you actually do have to have a problem that actually has real customers, that your customers that you're actually writing the software for, not the people you're convincing with your slide deck to give you $1 million for your round C funding. That's not the customer. The customer is now the real customer, not your guys' buddies on Wall Street are trying to do some gambling. Actual customers are paying for your service and paying harder money for your service, whatever that is. And those are your true. When the customer becomes those people again, that's when we'll see software quality come back again, because it's expensive to run these operations for free. You can't run them for free on free money. You have to run them from the value that you're creating for your actual real customer, which is your end client who's actually using the software, not the people you're selling the software to, and not the people who are making the deals. Is this clear? I'm not being too redundant here.
try and make an argument that you need to do this for your financial well-being of your company or your career or whatever or anything like that. And I'm also not claiming that people aren't having fun or anything like that. They might not be. It may be that current software practices are really not fun for them, but it could be that, you know,
they're so awful. Like everyone's just complaining. It's like this is a constant complaint fest. But all you know what to do is just, hey, we got a new library. Oh, there's a new AWS service that we can take the load off of us, take the complexity. Really, is that what we're gonna do? We're gonna another conference-driven, conference-driven, vendor-driven development. Are we gonna? Is the sales guy gonna convince us? The sales guy is gonna fix all the problems? We're gonna say yes to everything, and by the time we figure it out, we've already got $1 million in that damn thing.
You just strap on your VR goggles and you download a bunch of frameworks and you get them all cobbled together eventually and you just play around with it and you had fun and it was okay, right? Who knows, right? So I'm not going to claim either of those two things because I don't think there's really any need to go down that route, because all I'm trying to talk about when we talk about bad code is like, what's our potential? Like what could we be doing? What could we be doing engineering-wise versus where we currently are? Are we performing up to that potential at all? Or are we actually kind of falling pretty far behind where we could be if we looked at what we could be delivering to our customers and to society?
If we didn't have all this complexity, this unnecessary complexity with all these different frameworks from all these different companies who are competing not for the best framework, but for the most clout. They'll get the best engineers to come over and on there because we're using React. We wrote React here, and that makes a difference. It's like, yeah. So the reason I'm jazzed about KMP is it's that one language, Kotlin, one set of libraries, one UI toolkit to do UI, to do Android, to do iOS, to do web, to do desktop, and there's also one IDE that's coming from one company that's writing the language, that's interfacing with Google. This is their one thing that they're doing. It's not like Microsoft, where it's a side issue with their C#, Maui, whatever the hell that thing is, or it might be not Google's Flutter, which is a great idea. Basically, what Compose is doing is running its a little block and taking over the whole machine, and you still have the native environment there. So if you really want to drop down the native stuff, you can still do that stuff. But Apple's not going to put that out. They're competing with Android? I don't think so. So they're not going to do a universal platform. Microsoft is trying to do one, but they're not going to be. They're going to still do their flavor with a C#. They're not going to do. They're not going to. I mean, they might have an IDE, so they maybe have an approach here, but it's still C#. It's not Kotlin. So it's not this refined thing. It's still this wanky thing. Ugh. But if people already know how to do it, hey, use that stuff. I'm just get jazzed up about KMP because I'm coming through the Android route. I'm seeing how much time it saved me and how easy it is just to take my Android skills, which are not much different than the HTML React stuff. You know, well, it is more, but they're taking a whole chunk of it away and allowing you to go forward on a different type of a platform. So that's the reason I'm jazzed up about it. It's that takes away complexity. I don't have to learn Swift. I don't have to do HTML. I can't do it if I need to. It's right there, but I don't have to. Like 95% of the app is all in Kotlin now, and 90% of the app is also the web, the HTML code is no longer a thing. Is now we're just doing Compose. Like so, and that also makes it more secure as well. So you can't just hack into that stuff. It's like very difficult to hack in to these KMP applications because they're not running in HTML. They're running in a container. And okay, so yeah.
If we took things more seriously, right? So I don't think
seriously it means like, okay, so what he's saying is like, look at the stuff that we're doing and adding, and is it really adding value to the customer? Is this unnecessary complexity or is this necessary complexity? Instead of adding the thing, can we take things away? Yeah, I mean that's what KMP's doing. It's like, can we take some of that stuff away? It's still there if you need it. But do you really need to do it? Oh, that's what I'm trying to promote with this adventure-driven development as well. It's like, do we really need to add all that stuff pre-bloat? Can we get some more customers before more customers and servers? Can we do that first, and then we'll go from there? Why waste time on these things that don't matter? I know it's hard to believe, but you only have limited time.
I think we have to do this. It's just if you care about quality, what are we talking about here? So that's what I mean when I say bad code. I say we're looking at something that seems like, boy, we should be able to do a lot better than this. Why aren't we, right? Now, it's important to distinguish between two things. I actually think, as an industry, we haven't done that poorly on algorithms. Algorithms are actually understood in some pretty...
There's libraries now, man. I mean, we all get jazzed up about it, especially game developers. Oh, it's algorithms. But for Android and for most developers, there's a library for that. As long as we understand what's going on underneath the hood, we don't need to write it again. I'll stop.
Profound ways. I think the people who have done all the work figuring out like order notation and what the complexity classes of things are, they haven't proved whether P equals NP yet or whatever. But at the end of the day, there's a lot of stuff we know. Like we know how to analyze hash tables and how to think about them. We know like what the properties are of a heap or what different sorting algorithms will do. Like we have a lot of ways of thinking about algorithms.
That's ended in the 80s. So we're moving on. Now we're doing how do we make our lives as developers as productive and straightforward and non-incidental complexity. How much levels of stuff do we need to have? How many libraries can we get rid of? How many can we do something that's simpler, that's more unified, that doesn't have to remind and change every 6 seconds because this whole thing underneath my feet's changing.
And furthermore, a lot of the advice you see about algorithms may not be awful. Like it's possible that in general, you can experience algorithms in a pretty sane way. You can be taught algorithms in a sane way. You can think
it's useful to know what that is, but it's not the key.
About them in the same way. That's actually, I don't think all that.
Leet code grinding. If you haven't leet code ground, you're not really a developer.
Unusual. So if I was to put a pin, if I was trying to point a finger and say, this is the place that I think that we're going wrong, algorithms and like the actual specific idea of specifically how some piece of a program is going to work algorithmically, it just doesn't seem like what we're really talking about when we're talking about the bulk of bad code as we perceive it or bad software as we perceive it. It's usually not like what sorting, algorithm did you choose?
Correct.
Usually what we're talking about is the mess of the rest of the code. We are having a problem writing all the code that glues these algorithms together, right? Like when we're talking about what we're actually going to do here, the problem that we actually have is not so much that like we couldn't sit down.
I'm looking at you, Gradle. I'm glad that the people at JetBrains and Kotlin are coming out with a new build system because Gradle's ridiculous. How that thing was put together, it's like that way a Winchester house. If you don't know what that is, you can look it up. It was a piece added on. The documentation's horrific. Like what it actually does and the error messages and where is this error happening? What is it? Why is this error happening? It's in some cryptic language. You have to get a Gradle build expert to get this stuff. No, that has to go. This is Gradle. It needs to be deprecated. I'm glad they're deprecating it because it needs to go. Total garbage.
Down and figure out what the proper algorithm is here for this. The problem seems to be more that we can't figure out how to connect these things or how to manage the infrastructure into which these algorithms are placed. Yeah. That seems to just not work, right? It seems to be like that is what's going on.
It's just they added on and added on and added on and added, and then stick back and say, okay, maybe we should rethink this. Like we got money in that. You don't understand. I'm a Gradle build expert. I got money in that rat's nest. That's exactly what we're dealing with. We're dealing with this guy who's got all the best practices in the world. I got 36 items on my checklist, and once I do 36 items, I know I'm good. It's like, no, dude, no. We need to have 5 items. We need 3 items in the checklist, not 36 items.
The Rails. And so the question is, how did we get there? In the old days, that really couldn't be the case because there were hard constraints on what you could ship. When a computer only has 64K of RAM in it, right? There's no way for that glue code to spiral out of control. There's no way.
Oh, it did. Oh, it still did. It died. They definitely did. But the microcomputer revolution was a refresh because this was spiraling out. The mainframes, which had it all locked, that was computers. They were all this crap. They were all this junk here. So microcomputer revolution was a constraint that made people start thinking about things in a different way. That it brought some sanity back, honestly.
Way for the infrastructure to be all that big to begin with. Right. So there was a natural
Turbo C, Turbo Pascal. When those things came online, it was like these super fast compilers and debuggers that took all this command line goofiness and like command line debugger stuff. Ugh. The fact that we had to use that stuff is always so terrible, and that's where all this stuff has come out of. It's still that sort of thing. So that stuff has got to go at some point. At some point, this stuff will be shoved aside, and some other new operating system that's universal that sits on top of all these microprocessors that allows us to play with these applications, extend them without having to rewrite the whole damn thing from the stack on up. We just extend our little piece like a plugin, but the whole application is available, not just one little piece of it.
Limit on what could actually happen there, and it seemed to be working to that effect. Nowadays, we don't have that, and it seems like we have never developed any replacement for it.
Correct.
So the question is, like, why? And
because of the ZERP. Because there was no pressure. Because we could just add all the people that could actually, that would have changed it. All they do is add more people to this particular problem, and those people are like, oh, there's a big fat problem here. We can make a really nice living. Really nice by making sure that this thing never goes away. And they've basically got that involved, and they've insinuated themselves into that. And the great old people were genius with that stuff because their stuff is total garbage. And as soon as we get something better, it's gone. And they really had a chance to like revamp that and do something different with it and do something more sane that wasn't such a freaking nightmare to deal with as a developer. Yeah. And if you want like an example of this, just take any application from 5 years ago and try to download it off of Git and try and compile it with the latest IDE and see how far you get.
In order to understand why we haven't developed a replacement for it, I'm going to have to talk a little bit about how you actually learn to make stuff like on a computer. And I realize it's going to sound very trite. Maybe to people who are listening to this who aren't programmers, it won't. But to people who are programmers, this is going to sound a little bit silly, right? But please think about.
Oh, they're all programmers here. Don't worry. Anybody who's not a programmer is not listening this far.
Actually think about this for a second, because if you actually think about it for a second, you'll realize that we all take it for granted, right? We all take for granted that this is going on, and nobody talks about it, but we kind of need to, right? So nobody's born knowing how to program a computer, right? And I know this better than anybody because I learned to program at a very early age. But before I could learn to program,
I came out of the womb kind of knowing now.
I actually literally sat. I was a little tiny child. I sat at a keyboard, right, that my parents had, my dad had. I would just type. I would type gibberish into the computer, right? And if you think about it.
So that's what I did when I went to the Children's Museum. I was like 8 years old, 7 years old, 8 years old. And I wandered around because they let me go in there, and there was no adult supervision. I was just walking around. I wasn't like being held by my hand or somebody. I was just, there you go, see you later. They dropped me off there for the day because my godmother lived in Boston at the time. And yeah, I found the computer thing, and I just started dinking around with it. It's like, this is how you load a program. This is how you run a program. This is how you stop it. It's like, I sat down the thing. There's nobody else doing it. And I was like, okay, I guess I'm gonna be the guy doing it. They're all fascinated with the laser. This like laser thing was next door to it. They're like, beep, 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 beep. But the computer's just sitting there and nobody's playing with it. I'm like, all right, I'll be the dork that goes and plays with it. And yeah, that's when I first started learning how to program. And that's exactly what I did. Press the buttons. The buttons are super cool. Nobody's telling me not to. And I thought, oh wow, it types out. So anyway, the typing, the tactile thing of the typing of the thing, and then getting the computer magazines, and finally getting my own computer and typing everything in by hand. That memory, that rote memory, is something I think we've lost, and we've lost the thing that you actually have to type, and the typing thing gets it into the subconscious, drives in the subconscious, and when you're that low to the machine, when you're the thing you're like the basic prompt, like these old machines they drop into basic, when you turn them on, and you just start typing the programs in and then hit run. I mean, you can't get much bare bones than that.
Like, you first learn to just input characters or something into a computer, and if you're young enough, they're literally just garbage. But soon, what you're doing is your brain, right, is training itself up to learn that only certain combinations of letters, right, only certain syntax will produce a result if you're using a programming language. This is why we call them languages, right? They have grammar, they have syntax, all this sort of stuff, right?
Exactly.
And so something in your brain, and we're not advanced enough technologically to know like what's actually going on exactly, but something in your brain is creating a filter and a generator, something that's able to produce valid syntax for a particular language, and also able to throw out ones of those that it wouldn't want or wouldn't need, or that don't get closer to something, right?
I don't know where he's going off here with this theory of how the mind comes out with stuff, because there's all kinds of ways it happens. It's a mystery, and we'll likely never understand how it works. But people have goals. People are curious. People want to try stuff. They try stuff. Things happen. Things they like it. They keep going. They try other things. They're like with a paintbrush. Most people you have a paintbrush to, they're not going to paint shit. But every once in a while, there's going to be 1 out of 1,000 kids who takes this paintbrush and he starts going, "Oh, what's this for? What's this do over here? What's this?" And then he gets super into it and he starts doing all this crazy drawing stuff. But just like handing a paintbrush to somebody doesn't going to activate their thing. It's like, no, they got to be curious enough. Nobody told me to go. Nobody showed me the computer. I was wandering around the museum looking at all the stuff, looking at all the exhibits, trying all the things they had, playing with all the stuff. Oh, it's just another thing to play with. And I was like, wow, this is like way different than all the other simple stuff here. This is way different. This is something unique, something that most people completely ignored it. And that's just how it is. I don't think there's a way to train this. It's an innate ability that if you're interested in it or you're not, and you're willing to go down the path, because there's all kinds of things in the world other than computers. I know it's hard to believe, but there's other things people want to do. And whatever, it's just whichever go down to. And you could say the same thing about Thai massage, because I got into Thai massage. I did it professionally for a while. That doesn't match with this filtered, predefined process. That thing's all over the place. There's no filter refine. Like, everyone's got a whole different style. Each practitioner develops their whole thing from doing what? Doing it. I don't know how else to say that.
It's got a metric. And so if you think about this in terms of like AI research,
I don't know about this metric thing, but I'll let him keep going.
or something like that, right? There's a training process. You have to train up some generator to generate things that are valid in the output domain. And then you need some kind of filtering process.
It's real computer-y kind of feeling. It's like, hey man, I'm just trying stuff. And sometimes I'll win, sometimes I won't. And hopefully I'll win enough that makes me keep going to try other things. And look at other people's stuff and be interested enough about it. But if not, I'm just going to ban and go do something else. What?
Process that's going to take and get you closer to whatever it is that you're trying to achieve with that generative process, right? And so this builds and builds over time when you're a programmer, right? It builds over time. And in your head, you start
or just as a person
to learn that you can make new parts of this, right? Like functions and things like that, or get new ones from libraries. And you're starting to think at like a higher level. So that generator is now generating things higher up, and again, filtering things higher up. And then finally, you look at experienced programmers, people who've been programming a long time, not necessarily good or bad, just experienced. Their code has to be very regularized, right? So that filter has dialed.
I've seen people produce I produce all kinds of garbage stuff. It just depends on what I'm trying to do and how much time I got. What am I trying to? Who's this for? It's not everything to be perfect. Everything has to be exactly the same. And I might want to run over this code a few times, but rewrite, throw it away, put it back. It might be my first draft, second draft, third draft. Like, well, it doesn't. There's no rhyme or reason to answer. It's like, am I getting closer to doing the thing I want to do, or am I getting further away?
In quite a bit. Right? They're throwing out a lot of possible options that would be legal in the language they're programming at, and only selecting from a very, very narrow set. So that generator filter process is producing highly regularized, very predictable things at that point.
I don't know about that. I come up with some pretty wacky stuff that I never came up with before, never thought of before. Like, it was not refined process. And I've been programming for a long time. So, I mean, his theory is a little okay.
We don't know what that means, right? And we can't understand it at a deep, physiological level.
Correct.
But what we do know is it means a huge possibility space has been carved off of that system.
Yeah, if you're trying to tie your shoelace, you're not gonna be trying to like go hunt for an elk. Like, it's like you have your directed goals. You have things you're trying to do. Like, I'm trying to get my shoelace so I can go for a walk, not drink a glass of water. Okay.
All know that when we first learned to type in Babel, just the literal syntax of the language, anything was possible, right? You just type anything in that was legal in the language and you could type it in, right? And over time, you lose the ability to type certain...
I got lots of syntax errors. Syntax errors. That was on the original BASIC. If you didn't understand what you're saying, just syntax errors. A lot. More than I should have reasonably expected. But I kept going. I was like, oh, this is interesting. And then I just dinked around, typed in commands, copied stuff that I saw from in the little manual that came with it, and finding other books in the library and copying those things. And people were like, what are you doing? My brother was like, why are you spending so much time on that? It's so stupid. I was like, I don't know. I just like it. It's just what I'm into. You're into your, whatever the thing you're into, snakes, rats, or whatever the hell you're going outside playing in dirt. I'm into think around this stuff. It's just goofy and weird. I get it. Yeah.
Things in. And it's not like you couldn't force yourself to. It's just you don't, right? So you've tuned the generator and the filter in your brain to just do a certain narrow subset of things.
Maybe you have. I haven't. I definitely don't like that whole I'm refined robot of code generator. Like, I quit code after I did my after my first exit, my first startup. I ran for 7 years, which I was totally into. Once that was done, I went off and became a yoga instructor. I learned yoga. I fixed my body because you definitely get wrecked by doing this job. And I was starting, got into Thai massage. How did I get into Thai massage? Because I was doing yoga. How did I get into yoga? Because my body was wrecked. I mean, how do you find these? You can't backwards rationalize the path. It don't make sense to me. But going forward, be like, what are you doing? You should be writing code like a maniac. It's like, no, I'm done for right now. I'm going to explore this other thing. So it's not always this refinement process.
And what we think when we think of experienced programmer is that was good. That was a good process. Now they're producing like good code or something, right?
The good code is if it gets done. Does it solve the problem that you have set out to do in some way, shape, or form? Did you learn something along the way? Are you getting paid money to do this? Is someone paying you money? Are they happy with what you're doing? That's good code. Now, there's another level to the game, right? It's like, can you extend it? Can you change it? Can you modify it? Can you come back 6 months and see what you're doing and understand? Can you pass it off to someone else? have you documented and written it in such a way that somebody else could look at it and go, oh, I can't understand what I might have to look at this a little bit, but you've tried to intentionally make it like that. That's a whole other level of the game, right? And that's usually not your prototype. That's usually not your first draft. You're not going to your first draft. Somebody's like, here's the book. It's like, no, that's your first draft. You do another draft. Like my English teacher, 5th grade, 6th grade. It's like, no, we're doing multiple drafts. What do you mean? I just want to rewrite it again. Yes, you write it again. Well, my hand. Like, oh, your hand. Do you want to be a writer or not? Do you want to write in English to be understood and seen and have an influence in the world? No. Well, my hand, man, so mad. I have to write it over again. Stop whining.
I know it sounded silly. Hopefully, though, when we get to the end there, you're not too disagreeing with me about the fact that something like this must be going on in our brains. So our brains have learned this filter process, this thing that's going on, and we all have a slightly different one, right? But anyone who's been programming for any appreciable amount of time has formed this somehow. Now, I like to think of this as a metaphor. In my brain, I always kind of think of it this way because I don't really know how else to think about it. And the way I think about it is exploration, right?
Yes. So I agree with the exploration thing. So this is why I got to give this word, courageative explore development, where you have to have courage and creativity if you're going to be going on the adventure-driven epic quest. Now, in the beginning, you're going to do the tutorials, and you're going to go with personal projects. You're going to think around with it. You're going to hopefully you'll retype them, not just copy them over and change pieces of it. You're actually typing them and going through that. Man, why that process? It takes so long. It's like, yeah. Your brain takes a while to take in what you need to have to do in the future, and you have to have this attitude of like, I'm just going to figure out what's going on. I'm going to try and see what's the next thing. What's the next thing? I don't know if I'm going to fail. I probably will. It'll probably be a condition, unexpected condition, or non-expected result. Oh, it's so terrible. I failed. No, you just didn't. Like, that thing works. Syntax error. The computer. That's one thing I liked about the computer is that it was ever patient. It was always there. It was always patient. It just says, I don't know what you're talking about, man. But if you told it the exact way and the way it wants it and the way it's set up and how it's set up to do its thing, it'll sing a song for you, right? But until you humble yourself and be on a fool's journey to go and humble yourself, if you fall down the mountain and fall down, you get up and keep going. That's the only time it'll come up. That's why it's the courage, right? You have to have courage because you're getting attacked. Like, this is a computer with this wall. It's like, no, I'm not going to bend to you. You bend to me. This is the product as well. This is the consumer, like your customer. It's like, no, I don't bend to you. You bend to me. You want my money? You're going to have to get it out of me fair and square. You have to solve my problem faster, cheaper, easier, more fun, more interesting, more something than what I got now. Otherwise, fuck off.
I start out in my code bases in some sense, and I think of that generator process as sort of being like almost like a navigator, right? Like at any point in time when I'm going to figure out like what I'm going to do in the code, I'm sort of like thinking like it's like dead reckoning a little bit. It's like, well, I think the answer is probably this way, and I'm going to try some things. Sometimes
It's called your rough draft. It's called just trying. You're checking out. You're looking for what I call here. You're looking for the cave opening. You don't know. There's like a bunch of different ways up. There's not a straight line. It's like doop 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 doop. It's a 1,000 little misdirections, especially when you're starting out. When you're starting out doing this reconnoitering up, doing mountain climbing on your own, oh yeah, you don't know where anything's at, and it takes a while, and most people give up.
Backtrack, right? And I'm trying to navigate, and over time, I'm trying to get to a destination that I believe is somewhere, but I don't know exactly where it is, right? Yeah. And maybe you've had this feeling as well, like this kind of feeling, like it's sort of a journey, right? It's not like things. The metaphors people normally use don't actually apply that well. It's not like architecture, right? It's not like other things where we do a lot of.
It's like discovering a new way to make a building, a new type of building. A new kind of building. It's sort of similar to other buildings, but yours to do a whole different building. It's just for this group of people, just to do this type of thing. Like Burning Man, like these weird structures that the people build. It's like, why would you build that? It's like for this purpose, it makes sense, right? But if you needed to go make this into a hospital, it'd be bad, very bad.
Solving first and then just kind of put it in there. UML diagram people have tried, right? But it doesn't seem to.
UML diagram. I understand what they're trying to do is just for the complexity of their applications at that time. It made sense, but it definitely didn't translate to what we're doing. Not batch mode, okay? Yeah, batch mode with a bunch of accounts. It's like, well, it goes into here and it goes into here. Yeah, UML makes sense, but like these massive applications, no.
Really go that way. It feels more like a journey where we're not really sure about the end result and we're trying to get there, right? And maybe the better programmers are kind of better at making that journey, and the newer programmers who have a lot to learn, it's worse, right? But it feels that way to me. It feels more
always bad. No. Even with programmers like who've gone down these paths, As soon as you pick up something else, oh, it starts all over again. Wah! I want to start over again. Yep, that's the way it is. That's why with the Kotlin thing, I'm excited because this is going to be a stable platform for a while. At least 5 to 7 years. Just get some stability and get a common interface that we can build on top of that can leverage your skill sets, 10 to 1 instead of 1 to 1. Yeah.
Or like that. And we don't have maps, right? We're navigators that don't know the lay of the land. So we're constantly trying to kind of figure out as we go. That's how I normally think about it.
It's called knowledge work. It's called, somebody had to make this map. How'd they make that map? Well, they had to go out there where nobody was before anybody made a map. So yes, we're map makers. Yeah. These applications, if they're good, they're solving a problem in a better way, faster, cheaper, more fun. Yeah, it's gonna be a new map. That's just how it is. New territory. Call it Blue Ocean or whatever the hell. I call it the cave opening. Like, you're gonna go off into some uncharted. There's nobody up there. There are people's like, don't go up there. There's nothing up there. It's like, well, I kind of smell something out there. I smell something out there. Sounds like might be a dragon up there. Some bull they might be able to get at. Oh no, there's nothing there. It's like the same stuff that what was it? Here, the same the attitude that IBM had. General attitude is that you don't have big problems in small markets. There's no market there, and we can't have a big problem there. So we thought the personal computers are very smart. Yeah, they did, and they got crushed. They should have like put the IBM mainframe stuff in second place and do the PC. And they might be a player today, but they're just second rate server farm. Okay, who cares? Okay, we do mainframes. Well, you do mainframes. Okay.
About it. And I think about when we're setting off on these things and looking for things, they could be very uncharted. We could be trying to go somewhere that no one's ever gone before, or we might be just trying to do something we do know pretty well and we kind of understand the route, but we might do a little bit differently this time because we know how the route went last time and we think we could improve it. Things like that.
Yeah.
Right?
Yeah, it's called going from your prototype to your MVP.
Now, sometimes this works great. We end up in a place that we it's fantastic. It's everything we dreamed of when we thought we were going to go there. Other times we just forget it. This thing ain't shit.
Oh, usually it's a wreck. Ship it. Usually it's a wreck. But here's the thing. If you know ahead of time, look, we're going to wreck one of these. We're going to wreck one of these boats. We're going to rake and writer with one of these boats and somebody's going to get lost and they're not going to come back. Right? But we're going to send out 5 boats, 3 boats. We're going to send out a few of these boats. We're going to send out one this way, one this way, one this way. And we don't expect them to come back. Right? But if one comes back, oh shit. Well, let's keep going on that.
Ditch the boat, take as much food as you can, walk across the iceberg, and let's hope that we encounter another human being before we all die, right? So it has sort of the same analogies in a way.
That's startups, man.
The way it ends is similar to the way journeys end in the real world too sometimes. Now the path we took to get there, I kind of alluded to this, has implications. We can think of that as how the development process went. So if this went really straight and clean, we were just like, okay, that was great, that was easy, right? If it was sort of really messy and kind of all the way around, really circuitous, or we had to backtrack a ton of times, maybe that was a rougher development process.
Yeah.
Okay. The place we end up is kind of how I think of what we've achieved, right? It's the quality. Like I did this journey, I ended up somewhere, and when I get there, I know, this is kind of why it's a navigational process with software. It's
we don't really know until we have product market fit and people paying money for the thing. We don't really know. It's all educated guess, right? It's all educated guesses and things that didn't go quite right and insights and trying a few of these things, going in these lead mines, dungeon grinds, your learn down slog, feature factory, lava lakes of direct competition, tons of fake agile doom, scrum coach, death marches, cargo cults. Doing a few of these and you still got it in you. You might you might hear about a cave opening somewhere that you might want to go run up and with your skill set if you don't get trapped in one of these dev agencies, right, which do well. You could do very well in here. Finding out somebody else's technical problems, the same technical problem every time, right? But you're going to solve it for somebody else. But until you want to go up here is where the happiness is. That's where the happiness comes in. This is how we do it.
I don't necessarily know exactly what the thing will be at the end. Sometimes I don't even really know at all what the thing will be at the end. But I will know when I get there or when I get close enough to it, right? And that's why it's a very navigational process, because much like a kind of function where you can only evaluate it at points and you can't predict really what it's going to be very well, we just kind of only know, if we're trying to go from South America to Africa, right, we will probably know when we hit land. But before then, we may not really know how it's going. But we'll know when we get there, and when we talk to people there, we'll be like, is this Africa? And they'll be like, yes, right?
Right, that's your customers. You're telling them, your customers will tell you, yes, you're closed, or we're not interested and don't care, right? If they're paying money and you got them somehow you found a problem that they want to pay money for, that's your evidence that you're there, and you keep listening to them, and you tame them, you meet all their objections, and you tame them, and they can be pet dragon. So it's like, fuck you, your objections, your stuff sucks, terrible. You don't mean anything to anybody until like, oh, well, this kind of works for what we're doing. Maybe almost become a pet dragon. And you still gotta feed it, and you gotta pay attention to it, and make sure it's doing well to keep giving up the gold. But if you could also sell to somebody else, they can go that become your that dragon's now somebody else's problem. They have to feed. It's like there's a lot of options, but until you tame the dragon, you're not doing the adventure. So that's where the evidence shows up. It's not this UI won a contest or we got nominated for the best back end software. It's like, no, it's your customers.
Or something, right? So we'll kind of know when we get there, but we won't necessarily know. And even when we actually get there, we might not know where we are exactly in that area either. Like maybe we were aiming for South Africa and we end up in, up in Egypt somehow or something like this, right? So I kind of think of it as where we end up is sort of the quality of the result. So what we're sort of saying when we talk about the bad code situation, right, is in these processes, I feel like we're just getting horribly lost. Like we're just kind of, not only are we just like kind of aimlessly creating these huge routes through things that are very wasteful and take way too much time and all these other sorts of things, but also when we end up somewhere, it doesn't really seem to be very good. Like it seems like we're kind of nowhere near where we wanted to be, right?
Yeah.
And it feels this way sometimes too. This is another reason I like this analogy. Sometimes in the middle of a development process or even at the end, you're just like, oh man, we totally lost our way. Like we can't even really see how we would get there. And furthermore, another reason.
Usually by starting off too fast and not knowing where we're headed for or talking to the customer. This is such a common thing. It's like so crazy. Like all we do is constantly talk about the customer before I did my startup, but I was just constantly talking about, that's how I knew my business, what to do. I didn't come up with it on my own. I talked to people. I listened to see. I threw out basic prototypes, little test things. I didn't take me long to make. They weren't fully fleshed out. They were just partial solution. I did a whole bunch of those. Most people and all of a sudden there's one I was like, oh, here's one. I was like, really, it's a throwaway. People were like, oh my God, I can't believe you did it. It's like, this is the thing you're all excited about, this thing. I'm like, okay. And then I just kept pumping out more and more. And that's that company Digifx just kept going with that.
That I like this analogy is because it feels this way in the moment too sometimes. Sometimes you're like, I just don't know what we would do to get past this barrier. It's very intangible in that way. You can't quite put your finger on why the code isn't coming out or what you should do. You're doing things that you thought, right, should get you further, and they're not. Or they're just knocking you back, or it just doesn't seem coming back. It's very it feels like being lost in a lot of ways. Okay, so in order to understand why that sort of process might be going wrong, I want to put the blame, because I have an opinion about what is to blame for this process going wrong. I just want to put the blame on how we construct that navigational process, that filter process in the brain of navigating what we're going to do as we go code, both institutionally and individually, how we do that. Building up
poorly. We've done it very poorly. Agile, Scrum, it's terrible.
That part of brains, I think we're now doing a horrible job. In the old days, the lack of resources, the 64K of the machine, the fact that it was a 6802 processor which could barely do anything, the fact that loads from disk took eons, meant that development of that process in anyone's brain who could ever get a program to work at all, they had already gone through the process of actually being very aware of what they were doing. Everything they did would either succeed or fail at all based on whether the software was any good.
That's what I got into it. It's either you worked or didn't. Either it was acceptable or it wasn't. This is not acceptable. There was very clear delineation, and there was no goofing around. There was and then it was up to you. Figure it out, right?
Right, because even us light.
That's where I started off. So all this other bloatware crap that comes in, it's takes you 2 hours to make a build. When I start off with basic, is you can type it in. The moment you type run, it was running. That was what I started off. So all this other stuff that came in between was I see it as mostly unnecessary. So you can see my point of view is this stuff is all crap.
Bit of being bad meant you couldn't get the thing to work at all in such harsh environments, right? It's sort of like if the explorers were trained in the Arctic, right? Then all of them died who weren't really good or didn't learn really fast.
Correct.
Right? So how are we doing this process now? Well, to a certain extent, some people are still doing it individually. And this
is before YouTube. These books were horrible. These programming books were just terrible. They had the blurb above the program was sort of this fantasy language. I skipped it most of the time because it was just nonsense. Tomfoolery, and you look at the program and it was just cluster. So that was my introduction to clusterfuck. Programming was programming in basic. Okay, this is garbage. There has to be a different way. And I definitely wrote a lot of programs in basic to know there's got to be a better way of doing this and this. So I've been following this trend. Is also we got to make this easier to understand, extend, modify, and those basic programs were definitely far from that.
that tends to also be highly coincident with people who maybe aren't causing quite so much of the bad code explosion, but probably everyone to a certain extent does work individually, and that's just you naturally experiencing things. There isn't like an external force kind of pushing at you there. You're just playing around and learning on your own. But the vast majority of these, the tuning that happens in those processes now doesn't come from that, because again, the resources are almost limitless there, and there isn't much of a weeding out process that can really happen. It's not like on an old home computer that was really difficult to use, where you would have to get good automatically because otherwise you'd never be able to do it, or you just quit and go do something else. So a lot of times where things come from is like classes, universities, things like that. It might come from like code reviews or like mentors. Like
code reviews. Look, when we did the code reviews back when I was doing it back before this 2012 came back, before this pre-2012 out and then post-2012. So pre-2012, we would just talk to each other. We would look at a code together, 2 eyes, 1 screen, or, two sets of eyes, 1 screen, and we would talk about it. And we'd talk about it, and then we'd change it, and then we'd talk about it some more until it worked. So this whole thing about the code reviews going on longer than like a couple back and forths without getting on the phone and talking about it is totally a new thing. It's totally an internet thing. It's very anti-human. It totally makes work suck because you can only convey so much through typed words. And reading those words and keeping them up to date and remember what everybody said, like it's way better just to talk about things together. So I hope the pair programming review comes back to a trend, or just you can do the PR like one thing, but as soon as we have a question or something, instead of going the back and forth, we record a video and then you put the video there. The AI can analyze it and make all the notes you want out of that stuff. But we're gonna have a meeting right there and we're gonna talk about it because the going back and forth in the PR is so freaking lame.
Like there's a programmer who ostensibly knows something and they're going to tell you that thing or tell you what to do. Maybe.
Yeah, it's not. And most of the time, if it's more than just a few lines, people are like, looks good to me. Looks good to me. They didn't really look at it. They didn't even download it or start it up and run it. They didn't even check it out to look at the code. How do you know what's going on if you just look at the code? Really? No, you have to do a real PR. You have to check out the code, compile it, run it locally. This is for front end stuff. You really want to do a code review, try the thing that happened, just like the programmer was supposed to do, and then get on from there. All right, really? I'll write a test for it? Come on. So this whole thing is really goofy. I think I think there needs to be a delineation between this back end work and front end work, because the kinds of things that happen on the back end, maybe you can do the stuff from PR. I don't know, maybe, sort of, kind of, but definitely on the front end, it's much more nuanced, and they can't get it. This text review stuff, unless it's just one word, it's going back and forth stuff. No.
Your boss is really mad and you did a bad performance review, or maybe he's really happy and you need a good one. So you're calibrating based on, that was good, that was bad, I don't know. You're gonna go read Stack Overflow, something like this, right? And you're gonna look at what people said in there.
God, I'm so grateful for this AI enhanced programming stuff, because this Stack Overflow is total dog shit. Like, I cannot believe this became the standard. This lets you know how bad the documentation effort was for these big companies, that this became the go-to. Not their documentation, this goddamn calamity.
What are the answers that are voted up? That's kind of like learning what supposedly you're supposed to do. You go to lectures, this lecture, for example, right? You're gonna listen to someone.
I don't know. These people in these classes just do not know the modern practices. They can't know. A lot of this stuff is trade secret. A lot of stuff is tacit knowledge. A lot of this stuff is people are keeping it close to their chest, or it's just not the kind of thing you just pass out paintbrushes to people and expect them to start painting masterpieces. Maybe it's just that's how it is. Maybe it's just some brains are set up this way. Maybe some brains are just more tuned to certain problems than other ones that can't be transferred. And just learning data structures, operating systems, languages, the Fortran and COBOL. We're going to learn C++. And like, that's really the problem. That's the issue. I think there's going to be a time in the future when computer science is going to be taken out of engineering and put into like social science or psychology or something, some other branch that's more humanities based, because a lot of the problems that we're coming up with are humanity problems. Like, how do you communicate ideas? How do you communicate effectively? How do you discover what the problem really is going on? How do you make it so it's easy for people to understand your thing and how to use it and how to put things together? Not how do I build a platform that scales out to 1 billion people? It's like, okay, that might be interesting, but you're probably not going to be involved with that effort. You're going to be involved with something else that's going to be solving some other smaller problem than 1 billion people on a market. We're gonna do the next Amazon. Oh, you're gonna be the next Amazon. No, I think that the days of the huge Amazon bloat thing is gonna get cut to pieces by these local mom and pop shops somehow, some way. Usually, probably this AI stuff may drive a lot of that. Let me see. I'm at 54 minutes. I'm gonna do the second half of this video. And part 2. So stay tuned for part 2. I rant more to the screen where you just guys happen to be there. And give me a like and subscribe, and I'll talk to you soon.